We are at our 8th tutorial, which is the last for this set of tutorials. Let's go! Build a survival prediction model. With the pre-processing operators we have discussed so far, you can blend and prepare most datasets for building a predictive model. In this tutorial, we will use one of the most widely used machine learning methods, namely a decision tree, to predict who will survive the Titanic accident. Of course, there is nothing you can do about this now, after the ship has sunk, but you can still use this model for similar situations and make predictions then. Should you really buy a third-class ticket when traveling with your family? The model will show. So we're getting into the interesting part of these tutorials. We're doing something very applicable. Let's go ahead and click next. Drag the Titanic data, add set role, connect it, and configure it. Set role is going to be added, and now we're going to set our survived to our label. Next, add select attributes to the process and connect it. We're going to select the subset of our attributes, and then we're going to pick. Now we're going to click and hold Control, then click on sex, then passenger class, then passenger fare, the number of parents, number of siblings, number of spouses. Then click the arrow to the right. Now we have selected them. The tutorial didn't ask for us to select any of these, which are age, cabin, lifeboat, name, port, and ticket number. Next, we're going to drag and drop our decision tree. It is found in modeling, predictive, trees, and we already mentioned it in our previous tutorials. Let's connect it, and then connect the output of our tree. And again, as you can see, the output of the tree is green, while the data it outputs is colored in purple, in the same color as all of our other data transactions. We're going to run our process, and we're going to see the results similarly to the ones we saw in our first or second tutorial. It is interesting to see that for women, family size matters more than passenger class. The behavioral pattern could be not detected for men. In general, men had a lower likelihood to survive. Women and children first, right? This example shows us that we can detect patterns within our data. Some of the patterns might be very logical and easy to explain, while other times we might find out something that nobody knows about, and we might be the first one to figure it out. And that's what data science is all about. Exploring data and explaining data in a way that will make more sense to us, and in a way that we will gather more knowledge from it. Let's go ahead and click next. You've finished the first tutorial chapter. You learned how to use the most common data pre-processing operators and even built your first predictive model in RapidMiner. This is an exciting moment. This is an exciting moment. So celebrate. Yeah, as I said, we finished the first chapter. Now we're going to answer the challenges, and then we're done. Can you find out how to restrict the depth of the decision tree, i.e., reduce its complexity? Why could this be a good idea? Well, let's answer that question first. As you can see, our tree is, well, it's not that complex, but it has a lot of levels. And to analyze it, we need a certain amount of time. But if we had only 3 levels on it, it would be much easier to analyze, understand, and draw principles back to real life. Now, if we go back to our design panel and click on decision tree, we'll see that it has a parameter that says maximal depth. Now, if we put 3 here and then rerun the algorithm, we're going to see the most effective pattern repeat, which is that for women, number of siblings or spouses on board is the main attribute. This is the women and children first. It is shown that this principle and this rule was followed when it comes to Titanic, and the data backs it up. I just realized that tutorial says to limit the decision tree to 4, so we're just going to rerun it with 4. And yeah, it shows that number of parents or children also matters. However, if you're a male, you don't have such luck, and you're probably going to die on the Titanic. The tutorial also explains that these bars, with these bars, we can recognize what's the distribution. So 161 males survived here, and 682 died. So the ratio, the death ratio here is 64.4%. And the ratio that we see of 64% is of all the passengers. So of all the passengers, 64% were men. Now, if we look at the data set for women, we can see that they form 34.9% of the passenger, and that their distribution is that 339 survived and 111 didn't. So women survived more than men, even though men were the majority on the ship. What would you say was the rough probability for survival for this group? How does this compare to the survival probability for men? That's a good question. So, in order to see this, now let's do this the old-fashioned way. Let's bring up a calculator. Let's look at the numbers. Of the total of 843 men, 161 survived. So 161 divided by 843 equals to roughly 90% of the men survived. Now when it comes to women, there is 458 of them, but 339 of them survived. So 339 divided by 458. 339 divided by 458 equals that 74% of women survived. Now I'm going to leave it to you to implement and see how to get these numbers using the design, because you can do it. It is very easy to do. We're done with the first chapter. I hope that you liked this. I hope that you learned something. And in the end, I'd like to say that don't forget that watching tutorials is great, but without implementing and using this knowledge from tutorials as just a way to resolve barriers is all that you need. So implement, do the work on your own, and if you get stuck, only then look at tutorials and see how to resolve things. Tutorials are a great way to figure out what you're getting into or how to do something, but they're not a great way to learn by looking. I don't think anything is. You can get the ideas right by looking and by seeing the example done, but only with practice and implementing yourself and practicing yourself and being curious about the things that you're doing is going to lead you to learning. Without curiosity, learning is very hard. I guess deadlines could motivate you to learn, but I found pure curiosity to be a better teacher, I guess. I hope you stay curious. I hope you learn something from this, and I hope that you're going to implement all of these tutorials by yourself and then go on and experiment with your own data sets. I hope to see you in some of my next videos. Leave the comments if you liked it, if you disliked it, if something was left unsaid, unexplained. Let me know what you think. Thanks again for watching, and see you next time.